All right, we're going to do the second free response problem from review day 15. They give us two particles in motion. One, we're given a table of its velocities, and the other one, we're given an actual equation. So A says, justify why there must be a time where the p particle's derivative, the acceleration of it, has to equal 0 meters per hour between here and here. Now, if you look at the table, it's pretty easy to see why those values are the same. So the average rate of change of VPT is 55 minus 55 over 2.8 minus 0.3, which is equal to 0. By mean value theorem, the acceleration, V prime PT, or you can just say the derivative, which is acceleration, must equal 0. And you might want to say something about VPT is continuous and differentiable. So anytime you want to talk about mean value theorem, it's always a good idea to mention that the function you're working with is continuous and differentiable. You got a point for recognizing this, and then a point for bringing up the mean value theorem. All right. Second one says use a trapezoidal sum between 0 and 2.8 to approximate the value of this. So this is a little cumbersome. Your values, you're going 0 plus 55 times 0.3 divided by 2 plus 55 plus negative 29 times 1.4 divided by 2, and then negative 29 plus 55 times 1.1 divided by 2. And if you do that correctly, you should end up with 40.75. So they gave just 1 point for all of that. So I mean, sometimes they'll give you 2 points or whatnot in previous years, but for whatever reason that year they just did 1 point for that. All right, now we have a second particle moves along and gives us their equation for this, and we were supposed to find the time interval where the velocity is at least 60 meters per hour. So basically, you're graphing this, graph a line at 60 and see when is it above or equal to that value, right? And it's at least, it's at least 60 for the interval 1.866 to 3.519174. Okay, I'm gonna, again, you don't want to round too quickly, so I'm gonna give it a pretty decent amount of decimals, and that was worth 1 point for finding that interval. Okay, then it says find the distance traveled during that interval. So distance traveled, I'm gonna do the integral from here to here. Now if I call this A and call this B, I can do from A to B. All right, so you're allowed to do that as long as you say, you know, let A equal this and let B equal this. And so I'm going to do absolute value of velocity to get my total distance traveled. And if you did that, you got a point for showing this and a point for getting 106.109 as your answer. Then part D says, well, what if that position at time 0 was negative 90? Using results from part B and from part C, what's the total distance between them? So in other words, they're trying to say, do you know where the position is at 2.8 for these? So for particle P, the position at t equal 2.8 is the integral from 0 to 2.8 of its velocity, which was 40.75. All right, we found that from before. For particle Q, the position at t equal 2.8 would be its initial position, negative 90, plus its integral from 0 to 2.8 of v of qt. And if you do that, you get 45.938. Okay, so the distance between them is just the difference between those. 45.938 minus 40.75, which gives us about 5.188 meters apart. So you got a point for doing this. You got a point for having the position correct at Q, and then a point for that answer there. All right, and that's how we do that one.